Good morning to all of you
Good morning,
in the
sir.
class of quantum mechanics. Today, the first unit is matter waves, and here we have to study the first point named as wave particle duality. Wave particle duality. Today we have studied this point. Okay. So, in previously, I have stated that de Broglie hypothesis. In de Broglie hypothesis, what de Broglie state there? Wave particle duality. But what is the previous origins of wave particle duality? Means in their durations, which scientist doing some research work about the wave particle duality and what are their theories and what are their explanation. Just in short, here we want to study the wave particle duality. The first thing is we study from Newton. Okay, the famous scientist Newton. So the nature of light is enigmatic since the days of Newton. Newton assumed light to consist of teeny particles called corpuscular. Means Newton assumes that light have teeny particles. Teeny particles. And he called it as corpuscles. He called it as corpuscle. And it is emitted by luminescence body. And it is emitted by luminescence body. Using this theory, Newtonची जी corpuscular theory होती, okay? Using the Newton's corpuscular theory, he could explain the phenomenon of Newton explained corpuscular theory. By using corpuscular theory, he explained the phenomenon of he explained the phenomenon of two things. First one is the reflection and refraction. Okay, means your experiments, we also study the reflection and refraction phenomena in your optics experiments. In your optics experiment, we study the phenomena of reflection and reflection. Okay, but this is only possible for reflection and refraction. Nextly, this theory fails to explain the phenomenon of interference of light. Means this theory explains the phenomenon of reflection and refraction, but this theory fails to explain the phenomenon of interference of light. Interference of light. Interference of light not explained by this theory. Means there is some limitations. There is some limitations to Newton's corpuscular theory. Due to that reason, Newton corpuscular theory is not explain the phenomenon of interference of light. Okay. Then what happens? Newton's corpuscular theory is only limited for the reflection and refraction phenomenon. It is not valid for the interference of light. This is the first point of view in the wave particle duality. Then second point of view. Second point of view of wave particle duality is three more scientists named as hygiene, Young and Fresnel. Hygiene, Young and Fresnel. After Newtonian theory, hygiene, Young and Fresnel theory is there. So what is this theory? This theory proposed the wave theory of light. Okay, hygiene, Fresnel and Young. Okay, there are these are the three scientists, hygiene, Young and Fresnel. They proposed the wave theory of light. Wave theory of light. Wave theory of light proposed by hygiene, Young and Fresnel. Hygiene, Young and Fresnel proposed the wave theory of light. Okay, wave theory of light. According to his wave theory of light, light propagates in the form of waves. Means, according to wave theory of light, light propagates in the form of waves. Okay, in the form of waves, just like the waves. Okay, light propagate in the form of waves in hypothetical medium. In hypothetical medium, it called it as ether. Okay, hypothetical medium. Hypothetical medium called it as ether. Okay, hypothetical medium called it as ether, and it is supposed to be present everywhere. Okay, means this hypothetical medium is supposed to present in everywhere, that is in vacuum also. Okay, means in vacuum, in vacuum also. Means hygiene, Young and Fresnel explain the wave theory of light for the waves hypothetical medium. We called it as ether, and it is valid for vacuum medium also. Previous scientists told that for propagation of waves there is need some medium, but hygiene, Young and Fresnel stated that in vacuum propagation of wave is possible at that time. Okay, means hygiene, Young and Fresnel state that propagation of waves is also possible in the vacuum medium also. This wave theory could not only phenomenon of refraction, but also polarization and diffraction of light. Means this theory is overcome the Newton's corpuscular theory. Means Newton corpuscular theory only explain the phenomenon of reflection and refraction, but Huygens, Young and Fresnel theory what explain? This theory explain the first thing reflection. Okay, then second thing is what is refraction, reflection, refraction. This theory explains reflection, refraction, also, but also reflection explains, refraction explains, but also explain the phenomenon of polarization, explain the phenomenon of polarization and diffraction and diffraction of light. Means this theory overcomes the Newton's theory. Okay, this theory overcomes the Newton's theory, and this theory overcomes the Newton's theory, Huygens, Young and Fresnel theory. Wave theory of light overcome the Newton's corpuscular theory, and this theory explain the phenomenon of reflection. Okay, explain the phenomenon of refraction, explain the phenomenon of polarization, and explain the phenomenon of diffraction of light. This theory explain four phenomena of light. Means Huygens, Young and Fresnel theory. This is the second theory about the wave particle duality. About the wave particle duality. Firstly is the Newton's theory. Second one is the Huygens, Young's and Fresnel theory. And third in the 19th century, 19th century, Maxwell theory is there. In the 19th century, Maxwell theory is there. So, what about the Maxwell theory? Maxwell shows that the light waves are electromagnetic in nature. Means Maxwell theory states that light wave have light wave have electromagnetic nature. Electromagnetic in nature. Okay. Firstly, anyone scientist told that electromagnetic nature of light waves. In 19th century, Maxwell explained that light wave have electromagnetic in nature. Means Maxwell stated that light waves are electromagnetic in nature, and for their propagation, no medium is necessary. Means he states that this theory shows that waves having electromagnetic in nature. But second thing is the more important in this theory. So what this thing? This thing they stated that propagation no medium is necessary. Means wave propagation, wave propagation, no medium, wave propagation, no medium is necessary. No medium is necessary. This is the very much important phenomenon. This is the very much important phenomenon that told us wave, for electromagnetic wave propagation, no medium is necessary. Means where electromagnetic waves travel everywhere in the earth atmosphere or outside the earth atmosphere. Means there is a no necessity to need the medium. Okay, there is a no necessity to need the medium, and this phenomenon stated by the famous scientist, his name is Maxwell stated that shows that light waves are electromagnetic in nature, and for their propagation no medium is necessary. Okay, for their propagation no medium is necessary. this is the this is the third phenomenon. Okay, first phenomenon Newton, second one is the Huygens, Young's, Fresnel, third one is the Maxwell. Then we move toward the next phenomenon. Okay, okay. Then later on, fourth phenomenon. Then later on, fourth phenomenon explained by the scientist Hertz. 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 Okay. Hertz produce electromagnetic waves in laboratory. Means first experimental breakthrough. Okay. Hertz produce Hertz produce electromagnetic waves. Hertz produce electromagnetic waves in laboratory. Okay, Hertz produce electromagnetic waves in laboratory, and wave nature of light was accepted. After production of electromagnetic waves in laboratory, what happens? Wave nature of light is accepted. Wave nature of light. Wave nature of light was accepted at that time. Okay, it was the past. It is the past tense. Okay, wave nature of light was accepted. Okay, means previously Maxwell stated about the electromagnetic in nature. Okay, waves is electromagnetic in nature, but Hertz produce electromagnetic waves in laboratory. There is a no proof before the Hertz. There is a no proof that waves are electromagnetic in nature, but Hertz produce electromagnetic waves in laboratory. Okay, Hertz produce electromagnetic waves in laboratory. At that time, the wave nature of light was accepted. Means wave nature of light was accepted. Wave nature of light was accepted after production of in electromagnetic waves in laboratory. In this breakthrough given by the scientist, famous scientist Hertz. Then after the fifth point is in 1887. 1887, the famous scientist Holwatch. Okay, the famous scientist Holwatch discovered the phenomenon of photoelectric effect. Okay, photoelectric effect phenomenon was discovered by Holwatch. Okay, only phenomenon discovered. Photoelectric photoelectric effect phenomenon. Photoelectric effect phenomenon was discovered by Holwatch, but he could not explain on the basis of wave theory of light. Mean not explain wave theory of light. He could not explain the wave theory of light. Means there is a limitation of Holwatch theory. Okay, this fifth point states that he could not explain the wave theory of light. Means 1887 Holwatch uh, explained the phenomenon of photoelectric effect, but he could not explain on the basis of wave theory of light in 1887. Then after the famous scientist Albert Einstein. Okay, we know that. Then after major breakthrough in the duration of the famous scientist Albert Einstein. All of you knows that the name of Albert Einstein. If anyone time people told about the name of scientist at that time, people just told two names firstly, Einstein and Newton. Einstein and Newton. So Einstein was the famous scientist. He discover the photoelectric effect. Okay, photoelectric effect and explain its phenomenon on the basis of wave theory of light. Okay, photoelectric effect. Photoelectric effect of Einstein. He explained the particle nature of light. Okay, photoelectric effect explain the what explain photoelectric effect explain the particle nature of light. Photoelectric effect explain the particle nature of light. It is the major breakthrough. Okay, it is the major breakthrough. Means uh, in this page the fourth point stated as this: Hertz produce electromagnetic waves in lab. In fourth point, Hertz produce electromagnetic waves in lab, but at that time world accepted that wave nature of light. Wave nature of light. The sixth point stated as that Einstein explained the photoelectric effect. And after the Einstein explanation of photoelectric effect, particle nature of light was accepted. Particle nature of light was accepted. And it is the major breakthrough in wave particle duality. Wave particle duality means previously we have explained that first thing is Newton's corpuscular theory. In that Newton corpuscular theory, he explained that the phenomenon of reflection and refraction. Phenomenon of reflection and refraction. But he fails to explain interference of light. Interference of light. Okay, he fails to explain interference of light. Then after that, the fourth point stated as that Hertz produces electromagnetic waves. Hertz produces electromagnetic waves in laboratory, and after that wave nature of light was accepted. Wave nature of light was accepted. But in the sixth point, we have observed that Einstein explained the photoelectric effect on the basis of which he stated that particle nature of light. Particle nature of light. Then after the seventh point, after Einstein photoelectric effect, one famous scientist is there, Compton. Okay, Compton, one famous scientist is there, and he could explain the packets of energy. Means light consists of packets of energy. When scattering of X-rays produces, at that time particle nature of electromagnetic waves are observed. Particle nature of electromagnetic waves are observed. Means means in the Compton effect 1923, after Einstein theory, the seventh point is that Compton effect in 1923. Compton used particle nature of electromagnetic radiation. Used particle nature of electromagnetic radiation. Particle nature of electromagnetic radiation, and explain scattering of X-rays by electron. Used particle nature of electromagnetic radiation. Previously, particle nature of light explained by Einstein also. Then after that, 1923, Compton used particle nature of electromagnetic radiation to explain scattering of X-rays by electrons. What he explained? Scattering of X-rays. Scattering of X-rays by electrons. It is also major breakthrough in wave particle duality. Means 7 point stated as this: Compton in 1923 used particle nature of electromagnetic radiation. In his particle nature of electromagnetic radiation, scattering of X-rays by electron, he was explained scattering of X-rays by electron, and we called it as Compton effect. We called it as Compton effect. Okay, so this phenomenon is called it as Compton effect. Then what that this seven phenomenon told us? Firstly, I have explained previous point in shorts. First thing is that your wave particle duality. First scientist is Newton. What explained? Newton assumed that teeny particles called as corpusculars, and Newton explained the phenomenon of reflection and refraction, but he could not explain the interference of light. Then second one is the Huygens and Fresnel. They could explain the wave theory of light, and he stated that wave nature. Just like this wave nature means that explain the hypothetical medium. This means it is the ether, and it is also valid for the vacuum medium also. But previous phenomena, Newton and mechanics tell us that for wave traveling, we need some medium, just like an air medium or other medium, water medium, etc. But in Huygens and Fresnel's theory, he could explain that in vacuum, propagation of wave is also possible, and by using this theory, reflection of light by using this theory, reflection of light, refraction of light, polarization of light, and diffraction of light, this four phenomenon was explained. And third point is that What is third point? In 19th century, Maxwell shows that light wave have electromagnetic in nature. Light waves have electromagnetic in nature. At that time, the propagation of waves, there is no need of medium. At that time, he told us that for propagation of waves, there is no need of medium. Then after, the fourth scientist is Hertz. The fourth scientist is Hertz. And Hertz told us that he produced the electromagnetic waves in laboratory. He produced the electromagnetic waves in and laboratory. At that time, wave nature of light was accepted. Means previously scientists only told us that wave nature, wave nature, wave nature, but no one can produce the electromagnetic waves before the Hertz. First time Hertz produced the electromagnetic waves in laboratory, and after that world accepted wave nature of light. Then fifth point is that in 1887 Hall watch photoelectric effect. Okay, uh, in 1887, Halwaj discovered the phenomenon. He only discovered the phenomenon of photoelectric effect, but not explain the wave theory of light. Okay, he not explain the wave theory of light on his phenomenon. So after that, the photoelectric effect was discovered or proved by the famous scientist Dr. Albert Einstein. And he discovered the photoelectric effect, and we know that his famous equation E is equal to h nu. We know his famous equation E is equal to h nu, and he could explain the particle nature of light. He could explain the particle nature of light. Then after the Einstein, seventh point in the wave particle duality is Compton. Wave particle duality is Compton. In 1923, he used the particle nature of electromagnetic radiation. Means in 1923, Compton used the particle nature of electromagnetic radiation for what purpose? He used the particle nature of electromagnetic radiation for scattering of X-rays by electron. Okay, he could scattering of X-rays by using electron. Means use of electron for scattering of X-rays by Compton in 1923, and this effect was called, or currently it is called as Compton effect. Currently it is called as Compton effect. Means these are the phenomena in wave particle duality. Means some scientists told us that it having the wave nature. Some scientists told us that it having the particle nature. Some told us that wave nature. Some told us that this is the particle nature. This question arises in true nature of light also. Okay, this question is also arises into true nature of light. Means electromagnetic radiation has to be considered waves in some processes. Means waves in some processes and particle in some processes. Okay, means sometimes it behaves like a wave, sometimes it behaves like a particles. But both natures, means wave nature and particle nature, not observed in simultaneously. Means not any one scientist told us that wave nature is also observed, particle nature is also observed. Means wave nature, particle nature, they differs. Some scientists told us that it is the wave nature, some scientists it is the wave nature, some scientists told us that it is the particle nature, it is the teeny particle, small teeny particle nature. Some scientists tell us that it is the wave nature, this is the particle nature. Some tell us that this is the wave nature, but no one can tell us that both natures, wave nature is also, particle nature is also. The process in which path traveled by light is considered. The process in which the path traveled by light is considered. The wave nature of light is applied, but the wave nature of light, it is the applied nature. That is the, for example, interference. Okay, it is applied for interference and diffraction. Interference and diffraction. Interference and okay, interference and diffraction. These processes in which there is a interference of light with material particle. These processes in which there is the interference of light with material particles. The particle nature of light is applied. Okay, the particle nature of light is applied nature. The particle nature of light is applied for what? Okay, means wave nature of light is applied for, this is very much important question. Wave nature of light is applied for interference and diffraction. Okay, then particle nature of light is applied for what? For example, photoelectric effect. Okay, Einstein explained the photoelectric effect. Okay, in his photoelectric effect, he told us that particle nature. Okay, particle nature means photoelectric effect, then compton compton scattering compton scattering. Okay, compton scattering, this is the main point of view in this wave particle duality. Means wave nature applied for, wave nature is applied for interference and diffraction, and particle nature is applied for photoelectric effect and Compton scattering. Photoelectric effect and Compton scattering. Thus, dual nature means, thus dual nature. Dual nature means wave and particle nature. Okay, thus dual nature means wave and particle nature come to be associated with light. Okay, both natures in the association with light, we have stated that, and this is the phenomenon. Lastly, we move toward the dual nature of light, means wave and particle. Okay, means light having the wave nature also, and light having the particle nature is also, both nature. So we called it as wave particle duality. Wave particle duality. For this purpose, this is the first point. Previous lecture we have explained the de Broglie hypothesis. Okay, in previous lecture we have studied, in previous lecture we have studied the de Broglie hypothesis. De Broglie hypothesis. So what is de Broglie stated that? He stated that wave particle duality. He stated that wave particle duality. In previous lecture, we have studied about the de Broglie hypothesis of matter waves in his famous equation. In his famous equation. What is his famous equation? Lambda is equal to h upon p. Lambda is equal to h upon p, where lambda is de Broglie wavelength. Okay, h is h is h is Planck's constant. H is Planck's constant, and p is momentum. P is momentum, and its formula is P is equal to mass into velocity. P is equal to mass into velocity. Therefore, lambda is equal to h upon mv. Lambda is equal to h upon mv, and this equation is called as de Broglie wavelength. Lambda means wavelength. This equation is called as de Broglie wavelength. In previous lecture, we have studied the de Broglie wavelength. Okay, what de Broglie stated that? De Broglie stated that light has dual nature. De Broglie stated that, what de Broglie stated that light has, de Broglie stated that light has dual nature. Means the light has dual nature, and de Broglie, for this phenomenon, de Broglie receives the Nobel Prize also. Okay, wave particle duality. When he explained the wave particle duality, he explained that wave nature also and particle nature also. Okay, wave nature also and particle nature also. In 1924, it became evident that light has the dual nature. Light has the dual nature. The phenomenon of like interference, diffraction, polarization, etc., explained by wave nature of light. Means it is the wave nature. Interference, diffraction, etc., explained by wave nature of light, and the phenomenon of photoelectric effect, Compton effect, explained by the particle nature of light. Particle nature of light previously. But 1924, de Broglie forwarded the suggestion that matter like radiation has dual nature. Okay. 1924 मध्ये in 1924 in 1924, de Broglie stated that matter like radiation has dual nature. That is the matter which is made up of discrete particles. Okay, that is matter which is made up of discrete particles, atoms. Okay, matter is stated that matter made up of atoms means in atoms protons are there. Okay, electrons are there, protons, electrons means small particles, etc. Okay, matter consists of protons, electrons, atoms, etc., might exhibit wave like properties. Okay, means protons, electrons, they exhibit wave like properties under appreciate condition. Okay, if electromagnetic radiation can act like a wave, if electromagnetic radiation can act like a wave sometimes and like a particle in other times, mean sometimes electromagnetic radiation sometimes behaves like a particle and sometimes it behaves like a wave. Sometimes it behaves like a wave. Then think like a electrons and protons. At that time, we think the particles like the electrons and protons, etc., should also exhibit the properties are in the motion. Means after that, after his suggestion of after his suggestion of wave particle duality, after his suggestion of wave particle duality, he made some arguments like first one is the nature loves symmetry. Nature loves symmetry. Then second one is the two fundamental entries, matter and energy must be mutually symmetrical as regard of their properties. Means matter and energy are symmetrical. Matter and matter and energy are symmetrical with their properties. Symmetrical with their properties. And third point is that radiant energy behave wave nature and exhibited material particle in motion must be wave nature. Means since radiant energy earlier believed to be wave nature, radiant energy earlier behaved to be wave nature. Radiant energy earlierly behaved to be wave nature. Exhibited particle nature. Exhibit and he exhibit which nature? Particle nature. Radiant energy firstly behave like wave nature and exhibit particle nature. The material particle in motion must have wave nature. Okay, but in motion in motion material particle in motion material particle have wave nature. In motion, material particle have wave nature. So, by using de Broglie hypothesis, some other theories are also discovered. And his famous equation is very much useful. It is famous equation. Which equation? Lambda is equal to h upon p. That is lambda is equal to h upon mv. This famous equation lambda is equal to h upon p, that is lambda is equal to h upon mv, is very much useful to calculate the wavelength of associated particles. Next lectures we want to study the problems also. Okay, in next lecture we want to study the problems also. At that time this equation is very much useful. This equation is very much useful to calculate the wavelength associated with their particle. Also, one equation is very much useful. E is equal to h nu. E is equal to h nu, photoelectric effect equation. Okay, photoelectric effect was discovered by famous scientist Albert Einstein, and this is discovered by de Broglie. These both are these equations are very useful to calculate the wavelengths of particle associated with that, and this equation E is very much useful to calculate the energy. Okay, to calculate the energy of that particles. Okay, so today what we have learned, wave. Today we have learned wave particle duality. Wave particle duality. In previous lecture what we have learned, de Broglie hypothesis. De Broglie hypothesis. In this lecture some previous explanation is also carried out of de Broglie hypothesis. De Broglie hypothesis. In next lecture we have studied some other phenomena also. Okay, so unmute your mics. All of you. All of you unmute your mic.